Hey everyone, my name is James Stone. I'm here from the Helsinki office here in Futurice. And today I'm going to be talking about learning from Elm, about increasing functional safety and confidence in React with TypeScript. First, I want to talk about my functional journey because it may not resemble everyone's, but it's kind of my own personal journey. But basically, it started with I was working on an internal project here, and I found some Lambda functions. I had no idea what they were. I was like, what is this? So I kind of deep dived into that, and that was kind of my first foray into what I might consider functional programming. Then React and Redux and some basic utilities, and I don't think this is really completely functional programming, but like map and filter and the use of that. And then I was thrown into like an Elm-inspired project, and this is where I was kind of thrown further into the deep end in terms of functional programming ideas, and used a lot of Ramda and Lodash, so this can be more functional or a bit messy, but I think that's throwing me kind of deeper into the pool. And I've been taking a course called Functional Light JavaScript by Kyle Simpson. Has anyone taken that course or read the book? All right, I highly recommend it if you have no experience with functional programming and you're excited to learn a little bit more about it. And then I'm also lurking on Slack, and I meant to put, I think, Flowdoc here, but I'm lurking there, and so I'm reading all this functional stuff. So I may not be responding, but I'm like absorbing like a sponge. And for me, sometimes the language makes it very difficult to understand the concepts, but I'm still kind of like, how can I go further? And what this has largely done is kind of ruined me in React ecosystem by looking at Elm and looking at more functional approaches. So that's kind of what this talk's about. It's about Elm and how I'm looking at that, the architecture, and the functional type safety, and how I'm trying to implement that in React. And the first part of this is going to be a bit more philosophical and maybe a little bit more interactive. So this is a great part in the Elm documentation, which has got some really great stuff. Can be very philosophic, very opinionated, but this one's called Culture Shock and Defensive Instincts. Defensive instincts from JavaScript developers, like, no! Right? We're going to fight them off. And so they make a bunch of declarations about JavaScript. Let's see if they're true. Maybe we could just do a show of hands. So the first one is JavaScript. The longer your file is, the more likely you'll have some sneaky mutation, which is kind of a loaded word, right? It's okay if you don't know what that means, that will cause a really difficult bug. So does anyone think this is true? I kind of agree. I'm kind of sad about it. It could be no mutations, but like maybe it's not code you wrote. Is there more hands? Maybe from a random person. Okay, a few more hands. Awesome. And so we're going to kind of go back and forth. So this is JavaScript, and then we talk about Elm. In Elm, it's not possible. Has anyone worked with Elm here before? A few hands. Would you agree? Is this statement true? Is it not possible to have a mutation in Elm? So it is. I believe it is true, as far as I know. And so I think this is kind of the big difference, right? Okay, JavaScript. Refactoring is, and I'm not sure what this means, it's extremely risky. Right? Who thinks this? I think, I'm like kind of halfway, I'm like, I don't know. I think you can refactor sometimes, but if it's just JavaScript. Okay. So sometimes it's like maybe less extremely risky. For me, this sounds like, you know, leaping off of a cliff and like pulling the chute at the last minute or something, and like. So I feel like it's maybe a little bit extreme, this example, but it is risky, right? Like you can change something, especially in vanilla JavaScript. You can run into all sorts of errors that are unexpected. Refactoring is cheap and reliable. And to be honest, I'm not really sure what this means exactly, but it's not extremely risky. So like, I don't know, it's like the minivan of refactoring code maybe. Or Volvo minivan perhaps, if there's such a thing. Does anyone from the Elm ecosystem agree that it's cheap and reliable versus JavaScript? 3, okay, so half the Elm people say. Okay. So I'm going to talk a little bit about the Elm architecture, and I don't have a pretty picture here, but you may have seen these like cool, like spiraling 3 parts of architecture. But in Elm, we have this idea of the model, which is the state of the application. And I'm going to talk about this in React just after. And the model is kind of like your data set. And then we have update, right? And this is a way to update your state. And this is directly from the Elm documentation. I'm just quoting from them. And then we finally have the view, which is a way to view your state as HTML. And I think the idea is that we go through and we have the view, we're seeing something, and then we have some interaction, then there's an update, and then that update changes the model, and I can't remember in which order they are, but we have this cycle that we're going through all the time, right? And it's like this very pure view, and I think it's actually not correct, because it omits things like side effects. So in React, and this is my opinion, but often we have this state, which is sometimes called a store provider. Maybe it's a Redux store, it could be different things. It's not so specific as in Elm. We have the idea of dispatching actions, which are action creators, sometimes in combinations with reducers. And we have the render, and I put this, the view and env star. I don't know if this is still even a thing, or React components. So React is kind of where we're rendering. And I think it doesn't have to be the case, but often, at least the projects I've worked with, Redux is handling the actions and the state. But I have this question, like, well, like, what about side effects? Did anyone see anything in the architecture about side effects? Like, I didn't. And this is like kind of where I got really interested in functional programming, because like there's side effects everywhere, and like how do you handle them? And so it's really not this perfect thing. There's another cycle of handling the side effects. And in Elm, this is called commands and subscriptions. And in React, does anyone know how side effects are handled the typical way? Any wild guesses?
Wherever you want.
Wherever you want. It could be anything, right? That's what I thought. It could be anything, usually Thunk or some other middleware, and everyone's got an opinion about this, and I've been on several projects, and they all use something different. And like usually the middleware is where the side effects happen, and they're all kind of magical, even the one I'm going to introduce, but the magic is in different places. Okay, so what does Elm say about commands? And I think this is nice to think about side effects. A command is a way of telling Elm, hey, I want you to do this thing. And it gives the example of HTTP request. We need to command Elm to do it. So there's some sort of runtime Elm, which to me is like a bit magical, because I don't know how it works exactly. And we're like, hey, Elm, do this thing. I think it's a good way to think about how side effects are going to work. And they're talking specifically about the commands here as well. And they say every command specifies which effects you need access to and the type of messages that come back. And I think this is where, for me, is the rub with a lot of the middleware in React Redux ecosystem, because there's too much magic, and you have this state, and it just kind of like magically updates. I don't know how, like, but it does, maybe, some point in the future. And for me, it's a bit too magical, and I feel like Elm is less magical. It's very predictable. And this whole thing got me thinking about how can we improve the experience when working with React. So my thoughts are use TypeScript, which I'm a big fan of, and this is maybe a given here. Is anyone not using TypeScript in the project? Okay, I don't see any hands. Side effects, I'm suggesting, and I have numbers here because I'm going to go through and kind of show you basically how to use this. Redux-loop, which is middleware, which is quite nice. The RemoteData pattern. And then the third thing, I thought the maybe monad. If you don't know what that is, it's okay. I'll try to explain as best I can in normal language, but the idea is to kind of just avoid nulls in general. And this will be for maybe a future presentation, but thoughts about decoders for runtime confidence. And if you've heard of like IOTS or something like that, it's a similar idea, validating the data at runtime. So Redux-loop. Redux-loop is middleware. I don't think I need to say too much other than that. Basically, what I would say is in all of these kinds of middlewares, you have some sort of magic. But here, the magic is in this loop. Like, so the loop is running, and I have no idea really how that works, to be honest. And it's okay, but everything else is clear and predictable. And I'll show an example of how that works. And it's also quite nice if you're interested in Elm, because it mimics almost exactly the same process. And if you're interested, I'll have this at the end of the presentation, but I have an example. I haven't like released this exactly yet, but I've got this RemoteData.ts kind of thing I'm working on a branch. And here's an example. So just like a lot of middleware, we kind of use this in the reducer. And instead of returning the state, we return a loop, and we pass into it the state, right? So this is sounding very similar to how Elm might have worked. And then here we have this anonymous function that we're running something. So we're running this get environment variable. So this is like, hey, like run this in the future sometime. I don't know when. And then it always either succeeds or fails. And I'll show examples of what happens there. So unlike a lot of middleware that kind of goes and updates the state kind of magically or automatically, this is going to always create like a new action every time it succeeds or fails. So to kind of just show how it might be used against an Elm example, and I'm not an expert with Elm, but we have like the model and we have the command message, and then we're passing in loading, and then we're getting async, the URL. So similar kind of idea, right? We're passing in the same things. We're passing in the state and the command that we're expecting. And if I take that example that I had before and kind of change it to Elm parlance, we're basically passing in the model, and then we're running the command, and then if it succeeds, we're updating, and if it fails, we update. And in React-ish parlance, we have the state, and we're basically running a side effect, and we're calling an action if it succeeds, or if it fails, it's an action. So this is an example of like what happens when it succeeds. Now, when it succeeds, we can do anything, data validation, really anything. But the difference for me between this and other middlewares is it's very explicit. Like I have to write this for every single time I'm calling something async, or every time I'm calling a side effect. I have to write a success and failure, unless I'm calling no-op. And I have to define exactly what's happening. So in this example, I'm basically taking that data and basically adding it to the state. Same thing for failure. So if I get some sort of error, I'm also going to add that into the state somewhere. So I missed my title here, but this is introducing this idea, right, of the same thing. This web data from Elm. And this is kind of the problem it solves. So we have this kind of pseudocode. If we've got data, then we render something. Otherwise, like you have no friends or data, right? So you have this kind of often, binary decisions. You have a Boolean. And I used to have on, at least the iPhone, I used to open it up and it used to tell me I had no friends, right, when it was loading or something. And so if you ever have like a loading state and it says you don't have any friends, or if you get no data and it says you have nothing, but it's not really correct, this is kind of the pattern that the web data is aiming to defeat. And if you're using loaded, then it's kind of the same problem, right? Your friends are loading, but it could just be that there's no data also. And sometimes people start throwing more and more Booleans, and it just adds a lot of complex logic. So this is kind of my work in progress remote data, and it's inspired by OSI, which I've worked, yeah, hello, awesome. And also Olivi, so hello, both of you here. And then Lemon.js, NVIE, is anyone? No, probably not. And this is kind of like README first documentation perhaps, but I wrote this first. But I wrote a quick philosophy, use Elm matched verbiage and static type, purely functional approach, flexible enough for use. So I found some other examples, but they tend to be more kind of object-oriented, class-based. So I wanted to write my own. And my goal is to combine it with an Elm-style decoder for runtime type enforcement after side effects induced by Redux-loop. So this is kind of my end goal with this project. What web data asks in Elm is there's 4 different states. There's not asked, loading, error, and success. And it's not really that much more complex than what we're talking about, but it's just very explicit. Does anyone argue that there's a 5th state, maybe?
If you already have some data, but you want to refetch it, what state is that?
Sure. So I would argue in this like very specific way, and I could be wrong from functional approach, then you would follow this process again and say that it's loading. Like, are you replacing the data? Then you're loading it again, and it's either going to succeed or fail, right? So if you're like polling something, I think you can just keep using this. I don't know that you need to go back to not asked. That's just kind of initial default state. Never been asked. But great question. Okay. So how does this look in TypeScript? Again, this is just showing something out of context a bit, but one of the changes I made is I added an error generic, so I can change the shape of the data of the error being passed, so it doesn't have to just be a string. Okay, and this is an example of like how I might use this. And so this is a very simple example where I have an error that's a string, and I'm basically having this remote data object that's a string, and I'm setting this initial state, right? And the initial state is not asked. And what's nice about this versus like loading or null, like it's very explicit. I know it's never been asked. It's never anything else. And so if you've ever worked with JavaScript like short circuiting or all this kind of stuff, like maybe it's working quite well, but then you start to get an error, the data is not what you expect, and then you get unpredictable results sometimes. So again, we're kind of going back to the same example I had before. And now I'm calling loading. So the way that Redux-loop works first is this is how I'm changing the state, right? I'm like, hey, let's run the command, and I'm going to change the state going into it. So basically, I'm saying now we're loading. So if we had any sort of loading indicators, like say there was not asked, like we never even started the loading process, but say we wanted a spinner or some sort of progress, well then we could start it based on this now. The data shape's different. And then if it fails, we just pass the error, and you can kind of see where this is going. But this is just much more explicit and much more specific, and we can create much more specific logic of like how to handle these error states, how to handle all the steps in the process. And again, so I don't know if you mentioned, but I'll be on Slack afterwards. So if you have any questions or feedback, like we'll definitely take it there, but still trying to have it a bit conversational. So this brings me to the maybe, or the maybe just nothing, or the monad, or it's sometimes called option or optional, I believe, in F#. And for me, like, I don't know that I can describe exactly what a monad is, but if you saw what I was talking about with web data, how it was much more explicit, how it wasn't kind of like a null or undefined, like we knew the exact shape of the data. This is the same kind of idea, but for like a more binary operation, but a binary operation on any kind of data type. So it's not a Boolean, but you might think of it, it's like it either is or is not. And for me, it's maybe a bit philosophical, but maybe something to experiment with. So the way that this is working in TypeScript, and in this case, I took it offline. I have the source that you can link to, but they took the site down. But I'm still trying to find out what happened to that guy and see if I can properly cite his work. But basically, we have, it's either a maybe, or, so a maybe is basically a type, which is just the type, or it's nothing, right? And it's never null, it's never undefined. It's one of these two types. Okay. So this is a state example where I basically have some numbers that are maybes, some strings, and that's defined as the data type. And you can see that I'm setting everything, right? It's either set to nothing, or in the case of the language, I set it to English, right? It's either the data type, so it's either a string with English, or it's nothing. So it's never any other thing, if that makes sense. And this is just kind of showing a short example of it. And again, if you're interested in this, you can take a look at the source that I have and play around with this and see how you like it, right? If you've never used maybe monad, if you've never used monads or this kind of functional approach in your TypeScript, you can go grab it online and try it out in your own project. So this is it.